Hello, everybody. My name's Kimber. I'm Emeritus Professor of Toxicology at the University of Manchester in the UK. I started life as an immunologist studying basic molecular immunology, but for most of my career, I've been at the interface between immunology and toxicology, with a particular interest in the way in which chemicals and proteins can cause allergic sensitization. Today, what I want to do is summarize briefly new approach methodologies and their relevance for the classification of respiratory sensitizers. The issue about chemical respiratory allergy is that there are a lot of problems of both toxicological and an immunological nature. First, there's an absence of an accepted or validated animal model. There's also considerable uncertainty about relevant routes of exposure for the development of allergy and the role, if any, of IgE antibody. There's therefore current reliance on the use of specific inhalation challenge tests or SIC tests. And the problem with these is they don't provide us with any certainty in terms of distinguishing between true respiratory allergy and non-immunological or irritant reactions. So there are significant challenges currently. But the landscape's changing. And this is because recently there have been the development of new immunological approaches which provide a basis for accurate predictive testing. Now, this was really based on the development of what are known as adverse outcome pathways. And this is mapping the pathways to the development of a particular toxic reaction or adverse outcome. And one AOP is number 39. And this is focused on the pathway leading to chemical respiratory allergy. And specifically what it does is to identify the key events which are required for effective sensitization of the respiratory tract by chemicals. And these key events, or KEs, reflect the pathway leading to respiratory allergy and also allow the development of methods that reflect the stimulation of those key events by chemicals. So by understanding the adverse outcome pathway and the key events leading to sensitization of the respiratory tract, we can focus attention on looking at those key events and determining whether chemicals will induce them or not. Now, when we look at the adverse outcome pathway, we can identify 4 key events. The first of these is the formation of a stable adduct with protein. For chemicals to induce allergic sensitization, they must form a stable adduct with protein. And it's become clear that for chemicals to cause sensitization of the respiratory tract, they selectively interact with lysine residues. So that's one key event, the first key event in the pathway to the development of sensitization. The second key event is the elicitation of inflammatory cytokine responses. Cytokines are molecular mediators of immune activation, immune responses. And it's become clear that one interleukin in particular, and this is interleukin 1A or IL-1 alpha, is necessary for effective sensitization of the respiratory tract. If we move on, we can look at the third adverse outcome pathway, third key event in the adverse outcome pathway, and this is the selective activation of dendritic cells, or DC. Dendritic cells are essential for the development of all immune responses because they effectively present antigen to T lymphocytes and promote their activation. And for the development of respiratory allergy to chemicals, we need the selective activation of a type of T lymphocyte called Th2 cells. So that's the third key event. The fourth key event is the activation of these lymphocytes that do the damage, that cause allergic sensitization of the respiratory tract. So there are four key events that we recognize, and we have now the development of NAMs which reflect the first three key events in that series leading to the adverse outcome. So considerable progress has been made in designing immunological tests, NAM methods, which allow us to determine whether a chemical can or cannot induce the class of immune response necessary for respiratory sensitization. So just to summarize, NAMs have been successfully developed to measure the key events that are required for the development of sensitization of the respiratory tract to chemicals. The second point is that the judicious use and interpretation of such methods should now provide a sound basis for the accurate identification of true chemical respiratory sensitizers and their differentiation from chemicals that cause reactions through non-immunological mechanisms. The third point to make in summary is that studies with methyl methacrylate illustrate the benefit of these new approaches. The results of recent studies with MMA provide an illustrative example of how these methods can be used to determine whether or not a chemical causes respiratory sensitization. And MMA is a suitable candidate for this because there's been considerable uncertainty about whether MMA causes sensitization of the respiratory tract or in fact causes reactions due to inflammation and irritation. The results of recent investigations with MMA with NAMs provides really compelling evidence that this chemical lacks the potential to induce allergic sensitization of the respiratory tract. Okay, thanks for your attention.